Okay, so let's do the next problem. We've got partial fraction decomposition, and we're looking at case 2, repeated linear factors. So the first thing again is to make sure that the fraction is proper. It is degree 2 over degree 3. And then what we need to do is we need to factor the denominator. Okay, so we can factor out an x, and that will leave us with what? X squared minus 6x plus 9. And then we see that this will factor into x times x minus 3 quantity squared. So here we've got an x which is a distinct linear, right? It's first degree, and it's there's only one of the x's there. Okay? And now we've got x minus 3, which is linear, but it's raised to the second power. Okay? So we now have 3x squared minus 13x plus 18 over x times x minus 3 squared. Okay, now for that one distinct linear factor, we're going to have a constant, call it a, over the x. And then for this x minus 3 squared, it's going to produce two fractions. One of those fractions is b, which is a constant, over x minus 3 to the first power. And then we're going to need another fraction, which is the c, over now x minus 3 to the second power. Okay? And if there was a power of 3 here, right, I'm just going to, let's say there was a power of 3, then I'm going to need to have one more fraction for it. And then it would be d over x minus 3 to the third power. Okay? But we have only 2. Alright, now it's our job to find the values for a, b, and c. So we're going to multiply both sides of the equation by this denominator here. Okay, so imagine that you multiply this left side by x minus 3 squared, x times x minus 3 quantity squared, and then you multiply the right side by that as well. Okay? You now have to remember that you're going to have to distribute that in red to each term in black. Okay? So here, these will just cancel each other, and you're going to be left with this numerator. It'll be 3x squared minus 13x plus 18. Okay? So if you take a over x and times that in red, the x's will cancel, and you'll be left with a times the quantity x minus 3 squared. Then this fraction times this in red. One factor of x minus 3 will cancel with 1 on top. So now you'll be left with b times x minus 3. And then here, these x minus 3 squareds will cancel, and I'm going to be left with cx. Okay? Now we can use the convenience method. Okay? We call that method 1 in class. I'm going to plug in some numbers to make things cancel. I can see that if I plug in x equals 0, then this term will fall off, will go away, and that term will drop off, right? So plugging in 0 into the left and right, that goes away, you're left with just 18. Okay, and that equals now what? 0 minus 3 is negative 3, squared is 9. So that gives us 9a, and then we immediately get a equals 2. Okay, now I can plug in x equals 3, and if I plug in 3, this term will go away because it'll become 0. I'll get a 0 here, and both of these terms will drop off. Alright, so if I plug in 3, what is that going to give me? Ooh, some big numbers here. 9 times 3 is 27. minus, well, 13 times 3 is what, folks? 39. And then add that with 18. And then you're left with 3 times c. Okay? All right, now 27 minus 39, that's what, folks? Negative 12. Negative 12 added with 18, that'll give us a 6. So now you've got c equaling 2, right? Okay, so now we need to go after b. Well, notice that I'm not going to be able to plug in any more numbers here that'll make terms drop off. So we could now use the second method, okay, setting the coefficients equal to each other. If I need just b, then I notice that the b would be involved with a what? X squared term and an x term. Okay, so if I were to distribute this x, I'd get this. So that means that I can set up an equation that involves b using either the x squared terms or the x terms. Okay, but now I'm going to have to FOIL this out as well. I'm going to have a times what? X squared minus 6x plus 9. Okay? And so we know that on the right hand side we'd have a what? A x squared, right? From this right here, from that multiplication, and you'd also have a bx squared. But that ax squared plus bx squared would then add up to give us the square term on the left, which would be this term here. Okay? So we can say that if you add a with the coefficient b, you get the coefficient 3. And now we know what b is because we've already determined what a was. So if a is 2, then we know that b is 1. Okay? And so now we have found our unknown variables, okay, a, b, and c, and now we know what our decomposition is. So I don't know, where am I going to write this? Okay. So, let me fix that. So the original fraction that we had was this, right? So the original fraction was 3x squared minus 13x plus 18, all divided by x cubed minus 6x squared plus 9x. Now we know that that will decompose or break down into 3 separate fractions where the a is what? A has been determined to be 2, so we have 2 over x. Then we've got b, which is 1, over x minus 3. We've determined what c was. C is 2. So we've got 2 over x minus 3 quantity squared. Okay, and that is our decomposition. Okay, and for those of you who are watching this in my Calculus 3B class, okay, if you were to integrate this fraction on the left, now you'd be integrating each of those fractions on the right. That would be integrated with what? Do you remember? A natural log. Okay, this would also be a natural log, and here you would make a u substitution. Okay? All right, so let's now look at case 3 on the next video.